a couple of things before we jump on in. So we're almost done the unit. I'm going to be covering something later on this lesson that I'm showing to you because you'll see it next year if you go into chemistry, but I'm not going to put that part of it on the test. But I'd feel bad if I didn't at least introduce it to you so that next year it's not a total, oh, I've never seen that before, but it's kind of brushing the cobwebs off. So this should still be review. Ionic versus covalent bonds. Remember, atoms are not happy unless their outer shells are good. You're getting this. Fancy word for outer shell?
Valence.
Okay, and they want to become their closest noble gas. So metals want to lose electrons because the closest noble gas is on the row below them to the left. Yeah. Non-metals want to gain electrons and become the closest noble gas to their right.
Is that the answer for steal/lose an electron?
I don't know. Let's see. There's two ways to get happy. You can steal or lose an electron. When we steal or lose an electron, what kind of a bond is that? Yes, say it. Yes. And I always remember when you're stealing something, it's all about I. It's all about me. Ionic. So that, in fact, in my brain, I almost think that ionic sort of rhymes with I want it, and I'm stealing an electron. Whatever, silly way you come up with to remember this. So ionic. And then the one I haven't talked about as much, and I'm not going to put this on your test, but you need to know it or should be familiar with it for next year. When we share an electron, we cooperate. Covalent. And specifically, what I'm not going to cover this year is there's a totally different naming system for covalent bonds. So you learned the IDE rule for ionic bonds. Covalent, it's different. Of course it is. So, metal and a non-metal is always ionic. Two non-metals is always covalent. Good day, my angel. Can you wash your hands? And then Cassandra, can you get her organized? Show her where we are, lesson 7 in the periodic table and all that. If you can't find it, give me a wave and I'll pause and get it there. But I'm just going to keep going where we are. Okay? Cassandra, zoom up a little bit. Can I zoom in? Ionic and covalent go there. Not much more because I can't get it all on one screen. Cassandra and Ava, I'll get there in a second, but what's important is I said to you, we're finishing off our first unit on chemistry today. So right now I'm thinking your first unit test is going to be Thursday, a week from today. But on Tuesday, I'll explain to you, I'll give you a study guide. I'll show you everything that's going to be on your test, so don't panic. And also your quizzes count as tests as well. You're going to be getting a take-home quiz today. You're going to be getting one more take-home quiz on Tuesday as well. Okay? I'll explain that more. I'm putting a study guide together, and that'll be pretty identical to the test. So metal and non-metal, that's an ionic bond. Two non-metals, that's a covalent bond. I'm going to skip that for a second. I can't remember if I included that in your notes. I'm changing my old Science 10 where we had a textbook and things, and I'm kind of modifying it for the quarterly system, so bear with me.
I skipped it.
This right here, diagrams of compounds, you can make a little note here, not on test. I'm going to show this to you, but I'm not going to have you draw Bohr diagrams or Lewis diagrams of compounds. Kaylin, I will ask you to draw Bohr diagrams and Lewis diagrams of single atoms or ions, but I won't have you do combinations of them. They're cool, but that would take me another 3 or 4 days to explain, and on the quarterly system, I got to cut corners somewhere, okay? So make sure you make a little note, this not on the test. So diagrams of compounds. First of all, molecules of covalent molecules are individual. Sorry?
Can I explain what a molecule is?
Can you explain what a molecule is? What's a molecule?
A molecule is when there's two atoms,
I'm going to be fussy. Two or more
atoms put together
in some kind of bond.
in some kind of bond.
Yep, that'll work. But there's a bit of a difference between covalent molecules and ionic molecules. Covalent molecules are individual molecules. You can have one molecule of water. Most of you know the chemical formula for water. It's what? Yeah, and it looks sort of like an oxygen molecule and a couple of hydrogens, and they bond. You can have one of those. Ionic molecules, molecules of ionic compounds, they don't exist as little individual molecules. Instead, they're found as, here's the fancy term, I'm not going to ask this on the test, but you'll see it next year, an ionic lattice, Lattice. They exist as crystals. Salt, table salt, if you look at it through a microscope, it's a crystal. And they all need each other to support themselves in place. And the formula that we use is the lowest terms ratio of the ions. So here's a couple of pictures of ionic lattices. Here's a two-dimensional picture, but really they're 3D, and they're tricky to draw, but again, not on your test. Just individual, I-N-D. You know what you could do is you could go I-N-D-I-V period, and I bet you if you see indiv, D, I, V, I, D, U, A, L. There you go. Beauty. So, when atoms are close, I was going to put the word outer electrons, but let's use the fancy word. Let's put that there. They're valence electrons. By the way, you're seeing everything happens with the valence electrons, which is why a Lewis diagram, which only shows the valence electrons, is a nice, clear way to explain stuff. Okay? Their valence electrons can interact, and if the arrangement is stable, a chemical bond will form. And what is a stable bond? You need a full valence shell. Like a noble gas. And that's why the noble gases for the longest time we thought couldn't react at all. We now know we can get them to react a little bit in a lab, but basically they don't react. Have I told the noble gas walked into a bar joke? Yeah. Okay. Boy, there was some pain in that. Yes. I heard some emotional pain there. Mm-hmm. A noble gas walks into a bar. The bartender says, "We don't serve noble gases here." The noble gas doesn't react. So, little reminder, again, not on your test. An ionic charge is an ionic bond is a charge to charge interaction. You may have learned last year in Science 9, you might have done a unit on electricity unless it got interrupted by the COVID break. And so you may have learned that like charges repel and unlike charges attract. So an ionic bond, it's the unlike charges, a positive and a negative, attracting each other. And remember, covalent bonds share electrons. I want your electron, I for ionic. It's all about I. Let's cooperate and share covalent. Phone away, face down. Phone away, face down. Oren, can you put your phone away, kiddo? Thank you. We can draw Bohr and Lewis diagrams of compounds. We're not going to put this on the test. I'm showing this to you in case you see it next year. Cross out the word Bohr in your notes. We're going to do a Lewis diagram because Lewis diagrams are much nicer. Okay? And I think you have a gap, yes? A blank space? It says Lewis on yours? So I just forgot to change it in mine. Good. So yours already says Lewis diagram of NaCl? Does not? Okay, now I got to go look at the notes again. We'll pause for a second. So, first of all, what is on your test is being able to name this. What do I call NaCl? Sodium chloride. We use the ide rule. How many sodiums are there? What invisible number is sitting down there? How many sodiums are there? 1. How many chlorides are there? 1. If we do the Lewis diagram, it would look like this. First thing we do is we just write the symbol, nah. Mr. Dewick, can you tell me a joke about sodium? Nah. Can you tell me a joke about potassium? Okay.
Oh, you know what?
Now, don't write this down. Write the Na and then pause and look up. Look up, Ava, my joy. If this was a sodium atom, I would stick an electron there, but this is an ion, so it's lost the electron. And so to show that it's an ion, you can pick your pencils up. We put square brackets and a plus. Just hang on a second, kiddo. Just hang on a second. Then, chlorine. Again, I do the symbol. How many electrons does chlorine have in its valence shell normally? 7. So normally I would go, and I'll do this in red so you can see, 1, 2, 3, 4, 5, 6, 7. But this is an ion. It gained an extra electron. Where did it gain the extra electron from? Yeah, got it from the sodium. I'll do it in a different color as though that's the one that sodium gave. You don't have to, but that's just to help you see. And then because this is an ion, square bracket, minus. I'm not going to ask you to draw a compound Lewis diagram on your test, but I will ask you to draw Lewis atoms and ions on your test. So one of those on its own to me is fair game. Is that okay? And then, for what it's worth, there would be another chlorine there, another chlorine there, another chloride there, another sodium there, another sodium. This is what we mean by an ionic lattice. We're not going to draw all those in. Okay? Let's do another one. I think it's going to be turn the page.
You said something about potassium?
Okay. Oh, I do have a spot for a Lewis diagram of NaCl there. We did it there. Then it says Bohr diagram of NH3. I want to do the Lewis diagram. Scroll down on your notes to where it says a Lewis diagram of... Turn the page. See how techie I am? A Lewis diagram of NH3. I don't know if I included room for that in my notes, so I'm going to do it right here. Lewis diagram of NH3. So this one is going to be a bit trickier. First of all, is this ionic, and how do you know? What's the first element, Sadie, my joy? What does N stand for? You've got your periodic table. I need you to focus. You can do it. Is nitrogen a metal or a non-metal? So is it a metal or a non-metal? That means this must be covalent because it didn't start with a metal. That's how you know. If it starts with a metal, non-metal, it's ionic. If it's non-metal, non-metal, it's covalent. How many N's are there?
3.
Careful. How many N's are there? 1. Quickly, good money. How many 3's are there? Sorry, how many 3's? Wow. How many H's are there? 3. So how am I going to draw that? It's probably going to look like this. Don't write this down. I'm imagining it's going to be probably an N here, an H here, an H here, and an H here. Or I could put the other H up there, but there's going to be 3 H's and an N. Okay? So if you wanted to draw it as a Lewis diagram, you would go like this. You would put the N in the middle, put an H there, an H there, and an H there. Yep, that you can draw. Okay? That you can draw. How many electrons does hydrogen have in its valence shell? Look at your periodic table and count. 1. How many would it prefer? How many would it prefer? Look at your periodic table and count across. Hydrogen is in the first row. How many elements are there in that first row? 2. This is the 2, 8, 8, 18 row. So how many would it prefer? 2. So it's going to share each hydrogen is going to share 1 electron with nitrogen. How many electrons does nitrogen have in its valence shell? Count across. 5. So it needs how many more to get 8? 3. So it's going to share 1 electron from the 3 hydrogens. That's why this is a stable molecule. So how are we going to show that? You kind of got to use your imagination a little bit, but we do it this way. I'll do the electrons in red. Here, we're sharing 2 electrons. So now hydrogen has 2. Nitrogen right now has 2. Got to get 8. Here, we're sharing 2 electrons. Hydrogen has 2. It's happy. Nitrogen, still not happy. Here, we're sharing 2 electrons. This hydrogen has 2 electrons. It's happy. How many electrons does nitrogen have right now? 1, 2, Sadie. And it has 2 more of its own. These are what it brought to the party because it brought 6 of its own to the party. So if you really want me to be fussy, I'll do it in black. That electron, that electron, that electron, that electron, and that electron, and are from 1, 2, let me do this. 1, 2, 3, 4, 5, 6, 7, 8. Here's the 5. You said 6, it's 5. Here's the 5 that nitrogen brought in black, and the 3 that hydrogen brought in red. But now we have a total of 8 for nitrogen, happy, and 2 for each hydrogen. This is complicated, and this is why I said, Ava, I can spend several days on this. I'm not going to put this on your test, but I wanted to at least expose you to these Lewis compound diagrams so that if you see them next year in your science class, especially if you go into chem, you're not going, never saw that before. Okay? So again, you can make a little note here, not on test. Here's some Bohr diagrams of covalent compounds. I'm not a big fan of Bohr diagrams. Here's some Lewis diagrams of ionic compounds. This would be magnesium oxide. This would be barium bromide. And again, we're not going to do that homework there. So here's some Lewis diagrams of covalent compounds. So here is hydrogen monofluoride. That's what we would call this. I know. I'm showing you pictures, not on your notes. I told you, not on your test. Hang on, Raf. Here is a Lewis diagram of water. Here's a Lewis diagram of NH3. This is the one that we just drew. They put the H on the bottom, we put the H on the top, but same difference. This will be a Lewis diagram of CH4, which is methane. Okay? Yep.
What are we supposed to do for this side?
Nothing yet. Patience. Okay? Now, where it says diatomic molecules, okay? This is part of the next unit, so it's not on your test, but you are going to need to know this, but I'm going to include it in the notes in the next unit as well. Some elements are so unstable that they form covalent bonds with themselves. Some elements are so unstable that they form covalent bonds with themselves, and we call these diatomic molecules. And I'll do a big spiel on this next unit, but I'm introducing it now. What are the diatomic molecules? Most of us in chemistry remember a dumb joke. We call it Mr. Hofbrinkel or Ms. Hofbrinkel. Hydrogen is always, if it's by itself, H2. So where it says Mr. Hofbrinkel means, you can write H2. If oxygen is by itself, it's never by itself. It combines with itself to be O2. Can you guess what the next next element that's a diatomic molecule is? Fluorine binds with itself. Bromine binds with itself. Iodine binds with itself. Nitrogen binds with itself. And chlorine binds with itself. That's not going to be on this upcoming test, but it will be something you'll need to know. That's why you always, if you look at a chemical formula, you'll see H2 by itself. Or if you look at an oxygen tank, it'll be labeled O2, not just O. Because oxygen in there, I'm telling you, has bonded with itself to share its electrons with itself, so it's more stable. Mesa, you going to make it? You sure? Okay. So, in your notes, this part, not on your test because it's a compound. We're not going to be drawing Lewis diagrams of compounds. What would a Lewis diagram of F2 look like? We would have a fluorine here, a fluorine here. This fluorine would have 1, 2, 3, 4, 5, 6, 7 electrons. This fluorine would have 1, 2, 3, 4, 5, 6, 7 electrons. How did I get the 7, Nick? I just counted across on the periodic table. And then in the middle, here is where they're sharing electrons. So now each one can have 8 in its shell. Okay. The covalent bonds are much stronger than the ionic bonds, chemically. If something blows up, I guarantee that was a covalent bond. Much more energy there. I think I canceled that off your notes anyways, right? Okay. So what's your homework? That kind of brings us to the end of the chemistry unit 1, but we need to practice a lot of this. Let me pause for a second. So the first thing I handed you is unit 1, quiz 2. This is a take-home quiz, okay? Either I'm giving you the formula and asking you to tell me the name, or I'm giving you the name and I'm asking you to come up with the formula. If it's a multivalent ion, I told you the charge using Roman numerals. There are some polyatomic ions, ones from the back of your pink periodic table. So this is all a review of what we've been doing. And then in this column here, I'd like you to write the total number of atoms in the molecule. A lot of you are struggling with this. I'm deliberately allowing you to make some mistakes, and then when we mark it, we'll walk through. Hang on, I'm talking. Then when we mark it, you can walk through, figure out where you did it wrong, do your corrections, and get the marks, okay? This was from the back. This column here we did on the back of the Fun with the Periodic Table dumb jokes sheet, but I noticed as people turned it in that a lot of people hadn't bothered marking their answers by checking my answer key. They had just written stuff down. So this is my way of gently nudging you to say, you need to know how to do this, and especially in the next unit, being able to count atoms is going to become hugely important. I would, pardon me? For the quiz, no, but for the other stuff, for the Fun with Periodic Tables, it does. I fixed it, and it's also on your Teams, but we'll double check on your phone. You said there was a link issue? Yep. It's a good point. I fixed it last week, I think Thursday. No, what are we today? I think I fixed it Monday or Tuesday. It's a good point. What was I before Sadie made a good point? Once you finish this, hang on to it. I would love to, if I can, try and mark this in about an hour. So it's a take-home quiz, but try it here first. If you're stuck, I'll give you some hints, but I'm going to let you wrestle with this a little bit because I'd rather have you, Kaylin, when we go through it, have that moment and figure it out than me tell you the hints. Once you finish that, if you're still working on the stuff from last day, which was the drawing Bohr and Lewis diagrams, this handout, and then I've given you some more practice here, drawing Bohr and Lewis diagrams, one little sheet here. Okay? I'll put an answer key for this sheet both on Teams and on my website. And once we mark the quiz, I'll put a blank copy of the quiz and an answer key. Also, remember the first quiz. You can do your corrections on that. So we've got about an hour or so where we're just going to kind of press pause and you can work on stuff, okay? If you feel like you need a bathroom break, this would be a good time to take it. If you want to grab a quick snack, I'm going to say this. Anyways, we're done the lesson.